Okay, a hashing algorithm, what this allows you to do is it gives you some sort of way for finding your item immediately. So for example, suppose we have a bingo card and we're going to try and find N44. Well, we don't have to start at the beginning and search every single value. We could go straight to the ends and only search this column because we know our algorithm N means to find the column N and just search within this particular search space. So hashing is just that. It stores the data using some sort of algorithm, or in this case, a hash function, and then you retrieve the item using that same hash function. Let's give you an example. So here we have key is going to represent the item we're going to put into our hash table. We're going to stick it into a hash function, which will give us a hash key and tell us where to put it in the list. So suppose we're doing words and we just choose the first character. So apple has an A, we're going to put it with the zeros, and we'll put all the B's here and all the C's here and D's, E's, F, G's, and so on and so forth. So now when we get to the next one, we're going to put in grapes. Well, grapes has a hash value of 6 because we got A, B, C, D, E, F, G. So it's going to put the grapes in this position in the list. Then I'm going to do banana. Banana is the second one, so banana is going to go here on the second position because that's B. And now I'm going to do cantaloupe. Cantaloupe will have a hash value of 3, puts that in there. The problem with a hash table is you might come across some collisions. For example, I'll have cantaloupe in my hash table already, and I want to add cherry. And it has the same hash function, so we're going to end up with a collision at that point. And that's okay, so long as you have some sort of way of accounting for the collision. So maybe it's going to put it to the right of it and it's going to go off to the right. Maybe it's going to put it below it and you just search below it. And there's different algorithms for handling collisions, but in this particular class, we're not going to go into it. All you need to know is a collision might happen. Okay, modulus division is usually used to create the algorithm for your hash table. So here's an example of what modulus division is. It's finding the remainder of a division problem. So given 15 people in the room, you're making groups of 4. How many people are not going to be left, or how many people are going to be left out of a group? That's modulus division. Because if you look at this, we have group 1, group 2, group 3. So if we say 15 mod 4, that gives us 1, 2, 3 people that were not left in a group. Modulus division. Okay, so 15 mod is represented with a percent sign. Percent sign just means modulus division. So 15 mod 4 equals 3. Your turn. Tell me what 20 mod 3 is. Okay, you can use your fingers. 3, 6, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Gets to 18. So 19, 20 is left over. So 20 mod 3, there's our 20. We've got groups of 3, lots of groups of 3, but there's 2 people not left into a group. You could also count by 3s. 3, 6, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There's 19 and 20 not left in a group. So 20 mod 3 is 2. Okay, so let's show you how this works with our hash table. So I have a hash table that's size 7, which means if I'm storing this into an array, my values are 0, 1, 2, 3, all the way to 6. Now I'm going to randomly put a number in. So I'm going to put 22, and my hash function is going to be to modulus divide by the size of my list, or 7. So 22 mod 7, what's 22 mod 7? 22 mod 7 is 1. So it's going to put my 22 in position 1 of my list. Okay, let's do another one. 39. What is 39 mod 7? Need like the Jeopardy music here. Okay, 29. So if we take 7, 7, 14, 21, 28, 29, 30. Oh, this goes even higher than that. 35. I go up to 35 if I do 7 times 5. And so 7 times 5 is 35, and I got 4 left over that's not in a group, so my 39 is going to go in position 4. Okay, one more just to get this down. This is an easy one. Well, no, this might be a tricky one. Didn't think about that. Because 28 goes in evenly to 7. So that means I have a hash value of 0, and my 28 would go in position 0 of my list. Okay, next. Oh, I went out of presentation mode. Sorry there. Okay, 28. We just put 28 into our list. Okay, your turn. I'm not going to end the video because this is the last video, I think. So what you're going to do is you're going to pause the video, and given the following data, where would this be in this hash table given my hash function of n mod 7? Go ahead and hit pause, and then I'll tell you the answer in just a second. Okay, so our first value is 40. So n mod 7, or 40 mod 7. So that's what, 35. 7 times 5 is 35 with 5 left over. So 40 mod 7 is going to be 5, and that puts 40 in position 5. 14 goes in evenly, so there's no remainder. So 14 goes in the 0 position. Let's see, 7 times 3 is 21. So that means there's 3 left over. The 24 would go into the 3 position. 11, 7, there's only goes in one time. So 7, 8, 9, 10, 11 with 4 left over. Our 11 is going to go at position 4. And 20 is going to go in position 6 because you got 7, 14. That's the highest you can go, 14 all the way till 6. So 20 mod 7 is 6, and that goes in the 6th position. So now if you were looking to retrieve your information, you would just simply, suppose you want to say, oh, as 20 in the list. And I can go through and say, oh, 20 mod 7 is 6. I'm going to look here. Up, there's my item right there. So it's super efficient. You don't even have to iterate through the list. Okay, so now that you have your worksheet complete, I'm hoping, go ahead and submit that and move on to the next assignment where you can learn about some different sorting algorithms.